Hey, Algebra 2. Today we are going to look at the law of sines. Notice here it says the law of sines is used to solve non-right triangles. So that's a really important piece. This will be the first time we have looked at triangles that are not right triangles. Okay, so we use this when you have two angles and any side, or two sides and an angle opposite one of them. So like you learned in geometry, if you have an angle, and a side, or the side between the two angles, or the angle across from those sides, okay? If you don't have one of those scenarios, then we're going to use the law of cosines, which will be the next lesson. Okay, so all of these today will fit into the law of sines category. So basically what it is the sine of an angle over its side equals the sine of the next angle over its side equals the sine of the next angle over its side. So you just use what you have, and you should have, say, 3 of these 4 pieces, and you can find the missing piece. Okay? Or maybe you have 3 of these 4 pieces, and you can find the missing piece. Or maybe you have 3 of these 4 pieces, and you would find the missing piece. Okay, so let's look at an example here. So solve triangle ABC with these measurements. So of course the first thing we're going to do is draw the triangle. So we have 107 degrees. That's going to be a more than 90 angle. So we're going to draw that and label it C so that things are somewhat drawn to scale. So this is 107 degrees. We have angle B is 25, so I can put that over here. And I wrote A when I obviously said B. So this is angle B, which is 25 degrees. And then we have side B. And if you recall, the side is always the same letter as the angle across from it. So if this is angle B at 25 degrees, this is side B over here directly across from it. So that leaves us with this is angle A, this is side A, because that's across from the angle, and this is side C. Okay, so now we're going to solve the triangle, which means we're finding all the missing pieces. So we can fill in here that this is 107 degrees, angle B is 25 degrees, and side B is 15. Okay, we can also fill in angle A, because we know that the 3 angles of a triangle add up to 180. So we can do in our calculator 180 minus 107 minus 25. Okay, so if I throw that in my calculator, I can do 180 minus 107 minus 25 gives us 48 degrees. Okay, so angle A is 48 degrees. Okay, so now we're going to set up our law of sines to find side, let's see. So what we can do here is write down everything we have. So we have sine of angle A, we're going to write a capital A because we don't know that, over side A. Well, we don't know either of those. And we have sine of angle B, which is 25 degrees, over side B, which is 15, equals sine of angle C, which is 107 degrees, over side C, which is unknown. So we need to figure out which part of this we're going to use, and we can only have one unknown. So what we're going to do here is use this proportion, because we're missing one piece. And then how do you solve a proportion? Well, you cross multiply. So to solve this here, we're going to cross multiply. So we have C times sine of 25 degrees equals 15 times sine of 107 degrees. To get the C by itself, we're going to divide by sine of 25 degrees, divide by sine of 25 degrees, and then we're going to type that into the calculator. Go ahead and type in 15 times sine of 107 divided by sine of 25. And you should end up with C equals 33.9. So that side is 33.9. If you didn't get that by typing in your calculator, a couple things to check. First of all, make sure your calculator is in degrees. Go to mode and make sure radian is not highlighted and degrees is what's highlighted. And also make sure if your calculator opens up a set of parentheses here on the 107, that you also close that. Okay, so that this bottom doesn't get trapped in there. Okay, so we found C is 33.9. Now we still need A. Now some of you may be thinking you may have used Pythagorean theorem when we did that before, but of course you know that you cannot use Pythagorean theorem here because this is not a right triangle. So we cannot use Pythagorean theorem. What we're going to do is use law of sines again. Okay, so I can fill in on here that I found C is 33.9. Okay, and I'm still missing these two pieces. However, I actually did find angle A because I subtracted it all from 180, and this is 48 degrees. Okay, so now I can find side A by pulling out a couple different pieces. So now I'm going to use these pieces so that I have sine of 48 degrees over A equals sine of 25 degrees over 15. And again, we're going to cross multiply and solve for A. So this is going to be 15 sine 48 degrees equals A sine 25 degrees. We're going to divide both sides by 25 sine 25 so that that cancels. And go ahead and type that in your calculator. And you end up with A equals, you're going to type in 15 sine 48, end parentheses, divided by sine 25, and you get 26.376 or 26.4. So I now know A is 26.4. And that's how you use the law of sines. So let's do another example here. Okay, so go ahead and draw this triangle and put in the missing pieces. So we know that one of our angles is 100 degrees. So that's going to be a pretty big angle. So we want to go ahead and again draw an obtuse triangle so that this is 100 degrees and this is C. We've got another one 34 degrees. So this was B. That makes this A. And side B is 8. So across from there we have side 8. We're going to go ahead and find angle A by doing 180 minus 100 minus 34. So angle A is 47 degrees. So we're going to fill those in. And we're going to fill in side B is 8. And then we're going to set up our law of sines. Okay, and so if we just go ahead and write in all the different pieces, and we start with A, so we have sine of 47 degrees over side A equals sine of 34 degrees over side B, which is 8. And we have sine of 100 degrees over C, which we don't know. Okay, now we need to pick pieces to do that will give us everything that we need. So we can only have one missing piece, so I'm going to go ahead and use this, or you could have used the second two fractions there, and I'm going to cross multiply. So 8 sine 47 degrees equals A sine 34 degrees. We need to get A by itself, so we're going to divide by 34 degrees. And we end up with A equals, and we're going to type in the calculator, 8 sine 47, end parentheses, divided by sine of 34. And so for A, we get 10.5. So I'm going to fill in 10.5 here. And now we need C, so we are going to just pick different pieces. So we're going to pick these pieces here, and we're going to cross multiply again. So we get c sine 34 equals 8 sine 100. And we're going to divide by sine 34 to get c by itself. And type that in the calculator. We're going to type in 8 sine 100 end parentheses divided by sine 34. And we get c is 14.1. And there we have all of our pieces. Okay, last triangle we're going to do together. Again, we're going to draw our triangle and fill in our missing pieces. And once again, we have an obtuse angle A here, which is 115 degrees. So side A over here is 20. And then we don't have another angle this time. So I'm just going to label these B and C. But we got to make sure our sides go in the right spot. So side B is 11. So that's over here across from angle B. And side C is unknown. Okay, so if now we write up our law of sines, we're going to start with A, and we're going to say sine of 115 degrees over side A, which is 20. We have sine of angle B, which we don't know, over side B, which is 11. And then we have sine of angle C, which we don't know, over side C, which we also don't know. So we've got some unknowns here, more unknowns than we did the last time. So I'm going to start with where I have 3 things I know and 1 unknown, and we're going to cross multiply. So this is 11 sine of 115 degrees equals 20 sine B. Okay, now I'm solving for B. This is new this time, so I need to get sine B by itself. So to do that, I'm going to divide by 20. So now I have sine B on the right, and type the left side into your calculator. So 11 sine 115 degrees, close your parentheses, divided by 20. And I'm going to write out a few decimal places here. This is 4985. 0.4985 is the sine of B. How do we find a missing angle when we are given its sine or its trig function? Correct. We're going to do the inverse sine of 0.4985, and that will give us angle B. So you're going to type in your calculator second sine or inverse sine 0.4985, and that will give you angle B, which is 29.9 degrees. So we're going to fill in here 29.9 degrees, and we're going to fill in our other pieces. Of angle A is 115, side A is 20, side B is 11. Now we're missing both parts of C, which makes it impossible to use this. So we need to see if there's another way we can figure either one of these out, and we can, because now we can figure out angle C by knowing they add up to 180. So we're going to do 180 minus 115 minus 29.9. And we get 35.1. So this is 35.1 degrees. And now we can use this piece here, knowing that this is 35.1 and this is 29.9. So now we have sine of 29.9 over 11 equals sine of 35.1 over C. And we're going to cross multiply. So C sine 29.9 equals 11 sine 35.1. Okay, type that in your calculator and solve, and you end up with C equals 12.7. Okay, that's it for notes. Here are your video examples. You're going to do number 1, which will be just like 1 and 2 from the notes, and 2 will be just like number 3, and then number 3 is a multiple choice question. Good luck, and we'll go over these tomorrow.